So the next question that we're going to be talking about is, what results do you need? Now, can anyone tell me, when you run an aerodynamic simulation, what results do you need? Let me answer Sohan's question. So no boundary defined, low pressure area instead of a boundary. But Sohan, the whole idea behind doing the CFD is to determine how low the pressure gets. Remember, on the back side of the car, the pressure is lower, okay? So it's called PL. And the front side of the car, you have your stagnation pressure, correct? So this PS minus PL is ultimately going to be your pressure drag, which is what which is what you're trying to determine. So without doing CFD, you do not know what this PL is. So there is no way for you to guess that. Yes, but the backflow wouldn't then affect. I didn't understand. I hope you understand what understood what I'm saying, right, Sohan? Okay, cool. So what are some of the results that you need? Well, obviously, when you're designing a F1 car, right, you're looking at downforce values, you're looking at drag, and you're also looking at lift, right? These are the quantities that you need to predict correctly. And at the end of the day, they all depend on only two variables, your pressure and shear stress. So when you are solving the Navier-Stokes equations in CFD, it will calculate the pressure and velocity. Now your velocity gradient is going to determine your shear stress, and pressure is just computed from your continuity equation. Your velocity components should be in such a way that when you calculate a pressure, your pressure should be calculated in such a way that the velocity that you get should satisfy the continuity equation. This is called as pressure velocity coupling. This is a term that you might have seen in say ANSYS Fluent or any other software, right? So you need to be getting those results correctly. And from that, you can calculate your drag coefficient and lift coefficient. Now remember, drag and lift coefficients are normalized. They are unitless quantities. But at the end of the day, they're coming from your fundamental quantities of pressure and shear stress. So just remember that.